everybody, and welcome to this revision video on measuring and presenting data in psychology as part of the Stage 2 Psychology Science Inquiry Skills, or SIS. Let's get started. So, when we measure and present data in psychology, we use descriptive statistics, which are statistics that are used to organize and describe quantitative data so that they can be interpreted easily. So some of you may have gone through these measures of central tendency before, but again, a recap never hurt anybody. So often we summarize our descriptive statistics by determining a single numerical score that can describe the data for the whole group on the sample that we have used when we've collected our results. So this is called central tendency. So the most common measures that we use are the mean, the median, and the mode. So I'm going to talk you through each of those, and then later on we're going to talk about range and dispersion and standard deviation. So let's start with the mean. This is the most commonly used. It's also known as the average or the arithmetic average. So again, you may have come across this before, but we always calculate the mean score when gathering quantitative results in psychology, always. So to calculate it, you add the values together and then divide it by the total number of values. So as you can see here, I've got 3, 4, 5, 7, 2, 3, and 5. That's my data. We add those together. That gives us a total of 29. And there are 7 values there. So 1, 2, 3, 4, 5, 6, 7. So there's 7 of them. So we go 29 divided by 7, and that gives us 4.1. That is our mean or our average. We always calculate the mean in psychology because we need to know the average score in a data set and a data collection. Having said that, psychology, obviously we know that the golden rule is no two people are the same. So outliers are very, very common when we gather our quantitative data. So not only do we always calculate the mean, we usually almost always calculate the median as well. So the median is the score found in the exact middle of a distribution. And this is used when extreme outliers are present in a distribution. So an outlier is an extreme number that differs very much from the rest of the data set. So an outlier can be an extremely high number or an extremely low number, but it's an extreme number that doesn't really match or suit the rest of the data set, and it will skew the mean. So we always calculate the median to eliminate these outliers in our data. So to calculate the median, we put the values in ascending order, so in other words from lowest to highest, and find the middle number. So here I've got my first data set, so 3, 4, 6, 7, 8, 10, and 125. Now the median is 7 because there's 3 numbers below it and there's 3 numbers above it, so it's the middle number. So it's 7. Now that's all well and good if we've got an odd set of values. But what if we have an even set of values? So we've got 3, 4, 6, 7, 8, and 10 for this second data set. As you can see, we've got 2 middle numbers. So 6 and 7 are the 2 middle numbers because there's 2 numbers above 7 and 2 numbers below 6. So what do we do here? I'm glad you asked. If we have an even set of values, we add the 2 middle numbers together. So in this case, it's 6 plus 7 gives us 13. We then divide it by 2, which is 6.5. And that's our median for this data set. So if we have an even set of values, all we have to do is add the 2 middle numbers up, divided by 2, that gives us our median. So we always use the median if there are outliers, and usually there are in psychology. So if I calculated the mean of this first data set, as I've done down here, you'll see what I'm saying. So 3, 4, 6, 7, 8, 10, 125, all right? The mean actually works out to 23.2. So what's happened is this outlier has skewed the mean far too high. Now the mean doesn't really represent that data set very well because of that pesky outlier. So that's why we always calculate the median to see if there's a huge difference or discrepancy between our mean and median scores. So, important point here, gang. If the mean and the median score are very different from each other, like they are here, it means that there are definitely outliers in the data. In this case, it's an extreme high outlier. Sometimes, again, it may be an extreme low outlier, but an outlier is an extreme number, which then causes our mean to be skewed and therefore not represent the sample or not represent the data set. So we always calculate the median to determine if there are outliers in our data. Now, the mode is very straightforward. This is the most frequently occurring value in a set of scores. We only use this when data is in categories, and I'll give you an example in a minute. But the way we calculate it is simply by counting which value occurs the most times. So let's say this is our data set here. So 2, 3, 4, 4, 5, 5, 5, 6, and 7. 5 is the mode because it occurs 3 times. So it's the most frequently occurring value. We can have more than one mode. So if we had 3 4s and 3 5s, then 4 and 5 would be the mode. Sometimes we have no mode, so each value only occurs once, and then there would be no frequently occurring number, obviously. In that case, we would say no mode, or NA. We would never write 0 because obviously 0 is a number. So what I mean by it's used in categories, let's say I send out a survey to students in terms of, what theme you might want for formal or something like that. I would then count how many, 1s or A's or B's or C's or D's, or 1, 2, 3s or 4s, depending on obviously how I've organized my scale. And that's what I mean by it's in categories. So, all right, so how many A responses have I got? How many C responses have I got? Or 1, 2, 3, 4 responses have I got? So that's what's meant by we only use it when data is actually categorized. Okay, so those are the basics in terms of central tendency, but we need to look at this in a little bit more detail when we present our data in psychology. So we're still working obviously with quantitative data. So data in graphic form is used to make further inferences about the data. So we need to develop certain graphs or lines, line graphs or scatter plots or bar or column graphs, etc., depending on what it is that we're actually looking at. So in this slide, we're going to go through when each graph or what type of graph we should use when, depending on obviously what we're actually investigating. So line graphs and scatter plots indicates a relationship between two variables in an experiment. So for example, the amount of sleep a person has and how tired they report feeling, all right? So we always use scatter plots in particular when we use observational research. So if we use an observational research design, as I've talked about in a previous video, we always present the relationship between the variables, our IV and our DV, in a scatter plot to indicate is there a positive, negative, or no correlation or relationship between the two variables. So whenever we do an observational design, we always use a scatter plot. Now, bar or column graphs show how frequently a particular category of data occurs by using a series of bars that do not touch, and how many times it was said, as I've said there. So a particular category of data occurs by using a series of bars or columns. So for example, male versus female responses. So whenever we use an experimental research design, we always use bar graphs or column graphs, always. Sometimes we use histograms, depending on what it is we're studying. So this shows the frequency with which a particular score occurs in a set of data, and it's different to bar graphs because the bars in a histogram touch and represents continuous data, so such as age and time, so things that are still going on or continuing. These are also used in experimental research. So this is a typical line graph. This is your bar or column graph. This is your histogram, all right, where the bars are touching, and this is a scatter plot. So I'm going to come back to that in a minute, but first we need to talk about distribution and how that relates to scatter plots and standard deviation and things like that. So let's go through it. When we have a normal distribution or we get a normal distribution of data in psychology, what that means is most of the data are located in the center or the middle of a distribution, then tapers out to a few extremely high or extremely low scores either side of the middle. So this graph here or this image here is a normal distribution where most of the scores are clustered in the middle with only a very few high or low scores. That's considered a normal distribution. This is ideal for us, all right? It's ideal for researchers, but it's very difficult to achieve in psychology because no two people are the same. We are more likely to get more extreme scores. So because of that, this is the more common effect or result, a skewed distribution. So this is the goal, this is reality, or this is the expectation, this is reality, in other words, all right? So skewed distributions. Sometimes the scores are unevenly distributed, in fact, most of the time, and cluster to either the left or the right of the graph, okay? So if we have a positive skew, this is a curve that skews to the left, which indicates a clustering of large number of low scores. So this is, as we can see, a positively skewed distribution, so lots of low scores, in other words. Whereas negative skew is a curve skewed to the right, which indicates a clustering of a large number of high scores. All right, as we can see here, so skewed to the right, lots of high scores, more than what's obviously intended in a normal distribution. So these are skewed. So going on from that, variability of the values around the central tendency or the mean, median, and mode is what we refer to as dispersion. All right, and there's two main measures of that. There's the range, all right, which is used to calculate the difference between the highest and lowest scores. Highest and lowest score in a set of scores. So the higher the range, the more dispersed, in other words, the results are. All right, so ideally, again, we want a low range because it means that the distribution is more likely to be normal and not skewed. But again, that's usually not the case. So usually our range is quite high. So the higher the range, the more dispersed the results are, basically. The most common measure, however, of dispersion is standard deviation, which again, some of you may have heard before, but I'm going to talk you through how we actually apply that and do that in psychology. So the standard deviation refers to the average distance between scores in a distribution and the mean. So on average, what's the distance between the scores and the distribution and the mean score? So normal distributions has the majority of scores fall in the middle so that the mean, median, mode have the same value or very, very similar. However, again, that's not very, very common. So we need to look at the standard deviation. So scores that cluster closely around the mean have a small standard deviation. So in other words, they're not deviating much from the mean. So all the scores are around about the same as the mean score. Whereas the scores that are widespread from the mean have a large standard deviation. So they're deviating quite a lot, or they're much more spread out or dispersed away from the mean. So the deviation is large, hence the term. So let's put this into context, all right? Here's an example I would have gone through with you in class, or I will go through with you in class. So let's say a replacement teacher comes to a new school hoping for an easy day's work. The teacher is offered either of two classes, both with a mean IQ score of 100. The standard deviation for one class is 2, and the standard deviation for the other class is 5. So which class would she prefer, or he prefer, or they prefer? Since higher standard deviation means more variability in the data and the results, the class with the standard deviation of 5 may take more effort because they vary more in ability. So even though the mean is the same for both classes, the 5 standard deviation means that the students in that class have differing needs. All right, so some are lower needs, some are higher needs. Whereas the standard deviation of 2, they're all clustered closely around that mean of 100. So they're all around about the same ability level. So going back to what I talked about earlier in terms of scatterplot correlations, some of you may need to do this, all right, in terms of your design deconstruct. Even if you don't do an observational design, you still need to know what this means because you may get a question on it in a test or in the exam. So when we do a scatterplot, we're actually obviously looking at the correlation or the relationship, in other words, between two factors, all right? So we can have a positive correlation, a negative correlation, or no correlation. So let's go through what each of them mean. So a positive correlation is when as one variable increases, so does the other. So they both increase and both go in an upwards direction, as you can see here. So an example, this is from your workbooks, is the higher the revision time results in higher revision time, results in higher test scores. So the revision time goes up and so do the higher test scores, obviously. So as one variable increases, so does the other. That is a positive correlation. And that's indicated by going in both in an upwards direction, as you can see here. A negative correlation, as one variable increases, the other decreases, all right? So one goes up, one goes down, in other words. So higher avoidance behaviors results in lower self-esteem. So higher avoidance is going up and obviously lowered self-esteem is going down. So that is a negative correlation. So as one variable increases, the other decreases, and we can see that the scores are going downwards. So that is a negative correlation as pictured here. Sometimes we have no correlation, all right? There's no relationship between the variables that's positive or negative. There's just nothing. As we can see here, the dots are all over the place. There's no direction, in other words, of the relationship. So an example from your textbooks, there's no relationship between gender and results in psychology exams. So gender is not a factor in student success. So there's no correlation there. There's no relationship. So if you're given this in a test or an exam, you'll need to know obviously what these mean, all right? And if you look at, or you're given, you know, a blank one of these, you'll need to indicate whether they are positive, negative, or no correlation. So what we've talked about so far is how we organize and present quantitative data. But obviously, qualitative data needs to be organized and interpreted as well. So for this, we use a process called content analysis. So this is the process of collating and analyzing qualitative data, most often from a focus group. So often we'll run several focus groups. We'll get a lot of rich verbal data back, as I've said in my previous videos. But obviously now we need to make sense of it. We can't calculate mean, median, and modes of content analysis because it's in word and language form, not, you know, number form. So how do we organize content analysis, or how do we organize, in other words, qualitative data? This whole process of content analysis uses coding to process, or the coding process to make sense of qualitative data. So there's a step-by-step procedure in how we do this and how we organize our qualitative data. So the first thing is becoming familiar with the data. So we read it, we reread it, we read it some more, all right, until we're very familiar with what was said in the focus groups, for example. Then we start to look for reoccurring words or phrases that relate to the question, okay? So in other words, consistent answers, consistent words, phrases, sentences that keep popping up that relate to the question that we're investigating. So these are then identified as themes. So what are the common words or phrases or the consistent answers that participants keep saying in the focus group? We then examine those themes to find consistencies and patterns. So not only what are the words and phrases, but what are they actually saying? Are they in agreement with the question, or are they disagreeing with the question? You know, what are the consistencies? What are the patterns of what's being said? Once we've done that, we identify the common themes and give them a label. So give them a title. So this may be a 1 or 2 word title or label, just so later on we can obviously easily identify them. We count the number of times the themes occurred in the data. So how many times was that particular theme said in that focus group? Was it 10 times, 15 times, 20 times? And then we present those themes in a frequency distribution, which is a table. So we will have the theme, often an illustrative comment or an example of a common answer, and how many times it was said. So when we do content analysis, all we're doing is turning qualitative data in its raw form into quantitative data by putting it in a table and identifying the common answers, which are then labeled as themes, given an example, and counting how many times they were actually said. So turning qualitative data into meaningful quantitative data. So that is how we measure and represent our data in psychology, whether it's quantitative or qualitative. I hope you found this video useful. As always, any questions, let me know.